Hello and welcome everyone. So today we are going to learn smart contract hacking episode 0. So we are learning access control vulnerabilities, which is on the first in list of smart contract vulnerabilities, WASP top 10 list. So you can see here access control vulnerabilities is on number 1. So it's a very simple attack and very simple vulnerabilities, yet very effective. And in past, millions of dollars has been lost, and hackers have hacked the smart contract and withdrawn millions of dollars with these simple vulnerabilities. So let's see what is this and how to identify such vulnerabilities. So first we need to understand the visibility of function. So in Solidity, visibility of function can be public, external, private, and internal. So as mentioned here, public can be accessed externally and internally as well. So externally means any smart contract can call this function, and internally means the deployed of smart contract. So internally any other function can call this function as well. So public is super duper, it's uh, vulnerable, and we need to check which functions visibility we are making public. And if we are making it public, so if any access control is uh, applied or not. So external. After that there is another visibility is external. So this can be accessed externally. This function can be only accessed externally, it cannot be accessed internally. So within the smart contract, this function with visibility external cannot be accessed. So after that there is private. So private can be only accessed internally. So if another a smart contract tries to call this function with this visibility, the smart contract won't be able to call this function. So after that we have internal. So internal can be only called internally. So what's the difference between private and internal? So internal, in internal, uh, inside contract can call the internal function visibility, but also inherited contract can also call this function, which is mentioned internally. The visibility, the function with internal visibility. So the function within the same smart contract can call this function, as well as the contracts which inherit inherit this deployed and smart contract, they can also call this function. So we need to make sure where this internal is used and how it's being called. So what's the default visibility? So if no visibility is mentioned in function, the default visibility was public. So it was before version 0.5. So now Solidity version is almost 0.8. So before 0.5, the default visibility was public. So there are still some contracts which are deployed whose version are below 0.5. But if what if in current version or version above 0.5, visibility is not specified. So in that case the code will not compile itself. So the one fix is to upgrade your version to 0.5 or above that. So after that we have variables visibility. So variables have also public, internal, private, and default visibility is internal. So public, any contract can access it or call it. So getter function is created automatically for public. Internal or inside contract and inherited contract can access these variables. And private, only the inside contract, no inheritance. So default visibility is internal. So these are the visibility which are very essential in understanding access control. So when you are auditing any smart contract, so you need to make sure what are the visibility of the function to identify such vulnerability, access control vulnerability. So now let's see this code. see this function. Can you identify what are the issue here, and uh, is there any issue, access control issue? Pause the video and think. So you have guessed it right. So in this function send it, the visibility is public, but uh, there is no modifier or any access control check is implemented here. So anyone can call this send it, and they can transfer the balance to their account. So after that there is burn function. The same is here, the same goes to here. There is no access control checks applied here, and anyone can call this burn function and burn the token and amount as well. So now let's deep dive into some code. Pause the video and think, is there any issue here, and can you hack this contract? So let's go through this code. So this is basically ERC20 token, which has modifier only owner, which makes sure that only owner can access this contract. So there is constructor. So we are interested in this mint function, which is used to mint tokens to the address. And here the function visibility is public, but here we have another thing, only owner, which is a modifier. So which makes sure that only owner can call this contract. Let's look through the only owner modifier. So here modifier is used, so we cannot hack the contract initially. After looking at the code, so it seems that we cannot hack this, but let's go through this only owner modifier. So this modifier checks message.sender is owner, and after that it continues the execution of the code. So but it doesn't revert the function if sender is not owner. It's only checking whether the sender is or caller is owner or not. So after that it the modifier is continuing the execution of the code. So this is a classical problem here, access control vulnerability here, where anyone can call this mint function and transfer all the token to their account. So we will see this code in next episode, and we will do practical by implementing this contract and by hacking this contract. So that's it. Thank you.